Hello. Hello, ladies and gentlemen. Welcome to another lesson with Professor Checo, Pre-Calculus for Business. So today's lesson is going to be 5.3, Linear Programming in Two Decimals, Two Dimensions, a Geometric Approach. So here we go. Let's take a quick preview of what this is going to be. 18 questions. Cool. I'm going to now open up the textbook and let's just take a look at what we got here. Alright, so it looks like we are going to several problems discussed in the preceding sections are related to the more general type of problem called a linear programming problem. A linear programming is a mathematical process that has been developed to help management and decision making. We introduce the topic by considering an example in detail with intuitive geometrics. So let's just take a quick peek. So we got that, there. We want to minimize this, minimize that. So it's going to look like that. In order to maximize profit. And then you're going to want to figure out what that point is. Cool, any region. Alright, yep. Optimal solution is going to be right there. Got that. Alright, just determining the values. I'm just looking through this, anything like that. Alright, so here we go. The fundamental theorem of if the optimal value of the objective function in a linear programming problem exists, then the value must occur at one or more of the corner points of the feasible region. So looking at this diagram right here, when we get the solution, we're going to compare 0, 20, 15, 15, and 24, 0 into the equations to see which one of those is actually going to give us the maximum profit. But those are our, what they say here, corner points, feasible, yeah. Now, the existence of the optimum solutions, if feasible regions are covered by boundaries, then it's a maximum. If the feasible regions are unbounded, the coefficients are positive and minimum aren't, and empty. If there's no point, it satisfies all the constraints. Alright. Guide for it, graph it, construct the corner point table, determine the optimum solution for there. So here, I want to see this is our equation. We're going to minimize it to that, then we're going to graph it right here. So once we graph it, we got to check the three corner points and see which one gives us the highest value. So here, looking at that, 8, 4 would be, yeah, the minimum value occurs at 15 because they plugged that in. Cool. I'm cool with that. Here we go, corner value. So on this graph, we would have to check 1, 2, 3, 4, 1, 2, 3, 4, yeah, 4, and that's that, yeah, 1, 2, 3, 4 points. All right. So it really depends on what the graphs look like, right? Applications, we'll just apply this. So here's like the application. All right, moving on. It's just equations, right? Here, 10, 8, 10, 8, 3, 10, 8. C is, there you go, C is 3. Cool. Moving on. Inside, and then we're just going straight to the problem. So it's really just a bunch of graphing and figuring out the corner points and so forth. Alright. For the feasible set in the figure to the right, determine x and y so that the objective function 6x plus y is maximized. So what I'm going to want to do here is, let's take a, where's Desmos? Let's take Desmos and let's see if I bring this over here. And while here, if I were to work with the equation 6x plus 2y equals, and then x equals, I'm going to change this, I'm going to make this a equals, b equals 6a plus 2b. This is my easiest point, so I'm going to check 0, 0, which gives me 0. I'm going to use 10, 0, and that gives me 60, and then obviously I'm going to use 0, 10, and that gives me 20. So 10, 0 gives me the largest value. Alright, so now here we're going to construct the profit lines. Alright, now that I maximize, graph the, okay, so here we have these points. So let's see, we want to construct the profit, so the profit is x plus y through this. Use a straight edge to identify the quarter points and confirm your answer by constructing. So if we just blow this up a little bit, I'm going to compare these 3 points, and all it seems to be is x plus y, right? Well, obviously this is 11, this would be 16, this would be 13, so I'm thinking this point right here would be there. Use a straight edge to identify the corner point where the maximum profit occurs. The corner point to figure out where the maximum profit occurs. I want to say this one. No. This one, a positive slope. Correct answer is B. Oh. What are the coordinates of the corner with max? I'm still going to say that it's 11.5. And what were these values? This was 0. This is 13. This would be 16. And then this would be 11. Check answer. Okay. Alright, so then is it always like that? Got it. It's always going to be like that. Alright. So then this is going to be the same exact points, right? What are the coordinates of the corner points where the maximum profit occurs? What's my equation? 9x, 7y. Let's get Desmos over here. If I go over here, right? That's going to be Desmos. So now my corner points. So my equation here is going to be 9a and 7b. And then I'm going to check it. I'm going to do 0, 11, which gives me 77. And then we have 6, 9, which is 117. That's going to be the answer. Unless 13 and 0. No, that other one was bigger, right? 6, 9, 117. Oh, they're both the same answer. So that would be this one, right? Did I pick the wrong one? I meant to do 6, 9, 13, 0. Yeah, those two. They both had 117, right? 117, 117. I don't remember what this one was. That was 77. 77, and this one would be 0. Okay, there we go. All right. I think this is becoming very self-explanatory now. So this one should be going towards the origin like that. Got it. Continue. What are the coordinates of the corner point with the minimum cost occurs? We're thinking maybe 4, 2. Yep. Now you'll just plug those values in, create it, and do it. I'm just going to get this one wrong. Check answer. Cool. Check answer. Cool. Final check. Yeah, so just plug those values in, you'll get it. Boom, done. Alright, moving on. Solve the linear equation. So here, my profit. What is the maximum profit value of P? So let's see what this looks like. I'm going to go x plus 5y is, how do I need less than or equal to? Let's pull that up. Here we go. Less than or equal to 10. And then I'm going to get rid of this. I'm going to get rid of this. That was for the last question. And then I'm going to say where it's this region right here, right? So where x is greater than 0, x is greater than 0, and y is greater than 0. So what we're looking at is this region right here that gets overlapped. So what's the maximum value of P? I only have 2 constraints right here, so it either occurs at 0, 2 or at 10, 0. 0, 2 is going to give me 160, and then 10 0 is going to give me 200. So it's my P is going to be 200. What are the coordinates of the corner point where that maximum value occurs? I said that maximum value occurred at 10 comma 0. Alright, same exact thing here. So now I'm just going to change it. This is going to be 5x plus 7y is greater than or equal to 30. Delete 35. Okay, so now my corner points. So now the region that we're talking about is this region up here. Not this region, this region. So this is my corner points. So here, minimize. Which one of these can give me the minimum value? It's either going to be, that's 5, and that's 7. So it's either 50 or 77. Obviously 50 is going to be less, so that's the point that I'm going to do. So what would my minimum cost be? It would be $50, and that value would occur at 0,5. Cool. Alright. Okay, here, literally the same exact thing, right? So now we're gonna have two equations. After I get the region, I'm gonna skip past it because it's just gonna give us the same exact thing. So here we're gonna be subject to, what is that, 2x plus y is less than or equal to 30. And then I have a second equation where it says x plus 2y is less than or equal to 24. Alright, so now let's try to find this entire intersection. So I just want to see, I'm going to get rid of these two, just because I know that we're talking about the first quadrant, right? And now I think this is actually a lot easier to see. When I do that, it's too many shadeds. But, so here we go. We're talking about this first quadrant. Actually, what I should do is I should do it like this. Is less than. So now, when I actually look at it, it's like this region right here. That was. Can I make this one? How do I change the color? Settings. Black. Yeah. So now when I look at this, I'm gonna change this one to be settings. Boom. Let's go blue. There we go. I get that. So here when we look at this, this is the region that we're looking at. You see the equations, they overlap, and then there's my critical value. So now, select the correct choice. What is the maximum profit? Which one of these will give me the maximum profit if it's 9x, 9y? So this point right here is going to be 9 times 12, which is 98. 98. This one's going to be, this one's 12 times 6. And the only other question is this one, 15. I think 12 times 6 is going to work. This one's going to maximize our profit. So 12 times 9 and 12 times 6. 12 times 9 plus 12 times 6. Nine times 6 is 162. That should be the maximum profit. And now that point occurred at the intersection, which was that. So my intersection occurred at 12,6. Awesome. Alright. So now as you can see, this is a very similar equation. I'm just going to get rid of this. I don't need that. So let's modify these equations. 2x plus y is now greater than or equal to 20. Boom, 20. And then my second equation is x plus 2y is greater than 16. So now here we're looking at 1, 2, 3. Right? 1, 2, 3. So if I want to maximize, which one's going to be the minimum value of z? So I need to now plug this in to 2a plus 3b and add my sliders. And then my first point is going to be 20, 0. So that's going to be 0, and then this one is going to be 20. So that gives me 60, right? So this one right now is 60. What is the next one? This point right here is 8, 4, which gives me 28. Oh, that's the clear winner. Now that's 28. $60 still winning, and then this one's going to be 16. So that's 16 and 0. That's going to give me 32. So the maximum that we're still going to... So what is the maximum value of z? There is no maximum value? Because the graph is going up? I'm sorry, okay. I misunderstood the question. What are the coordinates of the corner with... there is no maximum value? What is the minimum value of z? That one was 32. That's this one, right? 16. That one's 32. What's 8 and 4? 28. Nope, 28 was the smallest. Sneaky, sneaky, sneaky. Alright, what are the coordinates of that? That was 8, 4. And now that should be the rest of the question. Done. Alright, so here I want to maximize this equation. So let's take a peek. I'm going to get rid of here. My equation now is going to turn to 30x plus 40y. So this is my profit function to 400. I need to be subject to 2x plus y is going to be less than or equal to, what is that, 10? And then x plus y is less than or equal to 7. O is a third constraint now. So let's put this guy right here. You know what, I'm going to move this guy, move these two equations up so I don't get confused. So it's 2x plus y is less than 10, x plus y is less, and then this one is x plus 2y is less than or equal to 12. So I think the region we're talking about is 1, 2, 3, 4. Can I put the, if I do the dots, if I do like 5, 0, will it plot it? Yeah, right? So I like that. I like that. Oh, that's cool. I didn't know I could do this. Nice. And then right here, right? Oh, it's so much easier. Can I put a graph? No, I can't. I was going to put, whatever, it's all good. But I think that makes it very clear, right? So now, what is the maximum value of P? I mean, I guess let's just do 5, 0, right? The next question is literally going to ask me for, so that one's 150. So can I label this as 150? Alright. Next one's 3, 4. And I'm going to label that as 250. And then let's see, we got 2, 5, so let's go here. So 2, 5, that's gonna be 260. Oh, here, here, 2, 5, I need to go 260. 260 and 0, 6, 0, oh, that needs to be 0, and this one's gonna go to a 6, and then I'm gonna label this, and it's gonna get labeled as 240. Wow, that was actually really cool. So now here, what's the maximum value that we can get? That's going to be 260. What are the coordinates of where this occurs? This occurs at 260, which is 2, 5. All right, so there you go. So this was a little extra, but I like that. That was pretty cool. I get rid of my points now. And the slider right there. So then for this one, you're going to minimize and maximize it. So I think this is just the same exact thing. You know, you're going to graph it. Let's just see what the graph's going to look like. So when we graph it, yeah, you're going to have this region where it's a point there, a point there, a point there, a point there. Minimize it, maximize it. Totally fine. So you can't maximize it because there is no value up here. So there are minimum values, but there is no maximum value. All right. I'm going to the next question. Minimize and maximize. Let's just see what this graph looks like because there are, oh, this one's going to be this region right here. Interesting. All right, totally fine. So let's just take a look and see what that looks like, just so we don't have any confusion. 5x plus 11, oh no, that's not the equation. Here, my equation is x plus 2y is greater than or equal to 16. My second equation is going to be 4x plus y is less than or equal to 43. My third equation is, was that -2? -2x plus 3y is less than or equal to 17, where x and y are both greater than 0. Oh, there's my graph. So my points are there, there, and there. And then I would just have to plug it into this equation, which says okay, all good. What's the equation here? 25x plus 10y, and then I would just go through these points, 8 and 11, and that would give me 310. And then I would do this again with the 2, 7, and that would give me 120. And then I would do it again with 10, 3, and that would give me 280. And then boom. So what is the question is, what's the minimum value? The minimum value is going to be 120. That occurs at the coordinates 2, 7. Maximum occurs at 310. That occurs at 811. Done. All right. Here, literally the same exact thing. So let me just view the example. Let me just see what it looks like when I graph this. Minimize and maximize. If this is my graph, there is no maximum, but there is a minimum. So here, what can you conclude with the optimal solution? Explain why you cannot conclude the optimal solution exists without graphing the objective function for various feasible solutions. Graph the feasible region of the graph and not determine the maximum value and the minimum value if they exist. Why can you not conclude that optimal solution exists? The feasible region is unbounded and one of the coefficients of the function is negative. Maybe. The feasible region is no, neither the maximum value nor a minimum value exists. That's false. And here we have I think it's that one. Yeah. What are the coordinates of the minimum value? So once you graph it, you'll get the minimum value, and then that should be it. I'm gonna get it. I'm gonna say it's gonna be either that one. What are the coordinates where the maximum value of z occurs? There is no maximum value. What is the minimum value? So when I plug in 10, 5, it becomes 5. Nice. Alright, the corner points of the bounded feasible region determined by the system of inequalities shown are here. Right, so there's my equation. Let's see what the viewing example says. What are the coordinates of A that will secure the maximum value of P occurs at C? Wait, what? What? What does this look like? So is that just like here? Okay, I would not put this kind of question on a quiz because gross. Oh wait, no, it's b is less than a divided by 2. Whatever. Alright, so here we have these equations and we're just asking where the minimum occurs. Let's see what they did here. I don't. Alright, let's get rid of these points. Let's see what this graph looks like. There's 2 of them, so I can get rid of this one. I could have just closed it. X plus 3y is less than or equal to 21. And this one is 12, and it's 2x plus y. So this is the region that I'm looking for, right? Boom, 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 and this one right here. What's my equation? It's going to be this one, right? It's going to be 6 if a is equal to, the minimum occurs at both O and C. O and C. If a equals 0, because if the minimum occurs if that value is the same. Alright, so here, a manufacturing company produces 2 types of water skis, a track ski and so. Alright, so we got these 2 types of skis. If the profit of the ski is $40 and the profit on the stem is 60, how many of each type should they sell? So here what we're going to do is we're going to graph this, right? So I think this equation was 10x plus 8y is less than 480. And I think this equation was 1x plus 1y is less than or equal to 50. gotta zoom out a little bit, and then it's these points, right? Now if I don't need these ones, right? 1, 2, and 3 are gone. Now my equation is $40, and then this one is $60. I need B back here, there we go. I'm just gonna put A in front of B because A is X. I need to check the point 480. That's gonna get labeled 1920. I need to check 4010. And that's going to get labeled as 2200. And then this one's going to be 0 and 50. And then that's going to be labeled as 3123. Okay, so the maximum profit occurs at $3,000 when 0 and 50. There we go. The maximum profit decreases they're just asking for this. What is this? 40 and 10. Create a new equation for the profit and calculate the amount of profit. I don't know, the maximum. What does the second part mean? No, I got that. The point A is the region. The x-intercept. Okay, we do. Okay. All right. Discuss the effect of the production schedule and the maximum profit in the profit. Construct a corner. I got you there. If the profit on a ski decreases to $40, the maximum profit decreases to there. So and this one is 0 and 50. Oh, if the maximum profit, if the ski decreases to 50. So what would happen if this went to 50? Now I understand the question. Okay. But now all these points just changed, right? So I gotta get rid of all these points and double check them, because this is now 4010. Oh, it's the same points. I just need to put it into a new equation. Oops. So then this is 050, which is going to be 2500. This one's going to be 4010. And then that's going to be 2100. And then 48 happens at 2420. My maximum is the maximum profit decreases to 2500, the maximum occurs at 0.50. Now I understand the question. My bad. Alright, so now what happened if it was increased to 70? So now if this went up to 70, right, this point, 4810, would go up to 2620. 4010. Wait, 48 0 will be 1920. 48 0, 48 0, and this new equation went up to, yep, okay. So now we're good there. And then now if I check 40 10, that becomes 2300. And then if I check 0 50, that goes up to 3500. So where does my maximum profit occur? It increases to 3500, occurs when 0 and 50. There we go. Nice. Okay. 1, 2, 3 more questions. The officers at a high school senior class are planning to rent buses and vans for each class trip. Each bus can transport 56 students, requires 2 chaperones, and costs that. Each van can transport 7 students, requires 1 chaperone, and costs that. Since there are 2,800 students in the senior class that may be eligible to go on a trip, the officers must plan to accommodate at least 2,800 students. Since only 22 parents have volunteered for the chaperones, the officers must plan to at least have 22 must plan to how many vehicles. Oh, goodness gracious. Okay, now this is a real life example, right? So we're going to kind of go through this into a way. Each bus can support 26x, so that's 26 students, and 2 chaperones. And costs 11. Yeah, I want this example. So students, 60x that's what it was. It was N12Y. So for us, it's going to be how many students can we get? So for each bus can do 56 students and then 7 students. That's 7Y. Must be less than what? What did they make it? At least 280 students. And then over here, I have for my adults, the bus is 2x. 1y is less than 22. Right, let me just see this example. At least, this one needs to be greater than, right? At least, let's see, to accommodate at least 280. So that guy needs to go this way. And the only region where they intersect is here, here, and here. Okay. Now, buses are X, which is going to be 1100. And vans are 80. And now we want to plug in 3, 16. And that's going to cost me 4580. and then we're going to plug in 11 0, and that's going to cost me 12100. And then we're going to do 50, and that's going to cost 5,500. Well, dang, right? This one's the cheapest. So we need 3 buses and 16 vans to minimize the cost. How much would it cost? It would cost 2580. Wait, what? $2,580. What are the minimum transportation costs? 4,580? Maybe there's a typo, because I'm pretty sure I had that. Hold on, let me view an example. I'm pretty sure I had that. Yeah, you find that the triangle, you find the corners. Oh, dang. Alright, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Alright. I'm pretty sure I have that. I don't know what happened there. All good. Alright, an investor had 7,500 in CDs and yielded at 5%, and minimum mutual fund investor at least twice as much as CDs, and mutual fund, how much should be invested in CDs. So here, let's see if they just give me the viewing example, because I like the table. The table makes it really nice. Do they do it? No, they don't do it. Alright, so for here, I'm going to get rid of my points, right? So to maximize my income, I have $75,000 to invest at CDs and a mutual fund. The CD yields 5% and the mutual field yields 7%. The mutual field requires a minimum investment of $9,000, and the investor requires that at least twice as much should be invested in CDs as a mutual fund. How much should be invested in CDs, and how much should be how much in the mutual fund to maximize the return? And then what is the maximum return? So let's go to the viewing example. So X is going to be the amount in CDs, Y is going to be the amount in mutual funds. So that's going to give me the equation there. With that, X plus Y must be less than, X is greater than 2Y, Y must be greater than 12,000. Those are my constraints, and I'm trying to maximize the interest. Alright, so now let's go ahead and graph this. So I have my first equation where X is going to be CDs. The investor requires that at least twice as much should be invested as CDs as that. So that means that I think Y must be, this is going to mess me up. Y is greater than or equal to 2X. So I do that. That's the region. I'm going to go back to view an example. Alright, so we have X is greater than 0, Y is greater than 0. So we're in the first quadrant. X is greater than 2Y. Oh, I had it switched around. and then y is greater than 12. So when you set those two equations, those equations up, you're going to get this. So let me clear this guy, this guy. This is still going to be our first quadrant, so let's go with less than or equal to 0. And then let's put a new equation in that says x is greater than 2y. X is greater than or equal to 2y. There's this equation. And then I know from my equation, they told me that I must have a minimum invested of 9,000. So that needs to be new expression 9,000. X plus y must be must be greater than or equal to 9,000. We're going to zoom out because it's going to be a much bigger graph. Okay. And then I'm sorry, x plus y is less than or equal to 75,000. That's the money that we have to invest. So 75,000. And then we want the mutual fund yield. The mutual fund requires a minimum investment of 9,000. So that's why its y is less than 9. Y is greater than or equal to 9, 1, 2, 3. And I'm going to put that here. I'm going to change that color just to something a little, not black, blue. Sure. Done. So I think the region we're talking about is this region right here. Right? There, there, there. To maximize the income. And now what's my investment? So my investment is equal to 0.05x, that's 5%, plus 0.07y. B and A equals B equals. Oh, I already have the sliders. Oops. I don't need these. I don't need this. Let's move this guy here because I no longer need this, and this has a double equal sign. So then now let's label, and then we gotta take, what is that, 18,000, and then 9,000, which would give me 1530. And then I'm going to plug in, what is that, 50,000, and then 25,000, and that's going to give me 4250. And then I'm going to plug in 66, and then we're going to plug in 9, and we get 3930. So which one of these is the greatest? We should be investing 50,000, 1, 2, 3 in CDs, and we should be investing 25, 1, 2, 3 into the mutual fund. And you'll get a maximum return of 4250. And there we go. All right, now this is the last question. So all of the government allows the plant to emit no more than 80 grams of sulfur oxide and 12,800 grams of particulate matter daily. How many gallons of the chemical should the chemical be produced by each to maximize power? So I want to maximize 60 cents per gallon and 20 cents. So then that should be one that says 60 and 20, subject to X, Y. Let's see. no more than 8,000 and no more than maximize that my profit is equal to 60 cents per gallon and 20 cents per gallon on the old and new processes, respectively. So my profit is 2x plus 8y. What's the actual answer? I had the profit right. Oh, they wanted me to actually write the equations in? Oh, I misunderstood the question. All right, yes. Let's go back. Okay, so I want to maximize it to this with 20 cents, 70 and 80. 70 cents, 20 cents. My sulfur oxide is the older process. Is 8x plus 24y is less than or equal to 8,000, and then this one should be 2x plus 8y is less than or equal to 19,000. No. Where did I get it wrong this time? Oh, I switched the y's. Did I get them wrong? I messed up the wrong y's. Mine, I just switched them. Everything else was right. 8x plus 24y. Yeah, I switched my two variables. I got it. Yeah, you combine the 8, the 2, you combine the 24 and the 8, and you get those equations. Under the stated governments, they would make a profit of, boom, so now I'm just going to go ahead and graph that. So now here, this is that, that's that. I think this is just the same exact thing, right guys? So this is going to be 8x, 8x plus 2y is less than or equal to 8,000, and then 24x plus 8y is less than 19,000, 19,200. Right, 19,200, and I don't need this constraint anymore. My profit is now 70 and 20. These are not my 3 points. And now let's find 8x plus 2y. 8x plus 2y is less than or equal to 8,000. And 24x plus 8y is less than 19. So then there's only this answer or that answer. Which one of those? It's either, what is it? It's either this or it's this. So it's either 0, 2400, which gives me a label of 48,000, or 0, 800, which is 56, 1, 2, 3. the maximum profit is going to be 56,123, and it's attaining by producing 800 of gallons of the old process and 0 gallons of product using the new process, right? No. Where'd I mess up? I'm there. I got it. 56,000, 48,000. Maximum profit would be 56,000. Obtained by producing 0 gallons and you 56, 1, 2, 3. No, I don't think this is right. No. This should be 800 and this should be 0. Oh my goodness, because this was in cents, this is 56,000 cents, which is $560, which is why I got it wrong. Oh my goodness, you sneaky, sneaky, sneaky people. How do I get the melee? What's the maximum? Okay. Now, if they want to restrict sulfur, sulfur was the first one. So if they want to bring this one down to 5792, what would that change? That would change our points of intersection. My new points would be here. My new point would be here, and my new point would be here. So now I would have to check. This point is going to be 724. And that's going to cost me 506.80. And then if I go to 496 and 912, that will give me a point of 52960. And last but not least, I'm going to check the point 2400. And that's going to give me the point 48123. So now the maximum that I can attain is going to be $529.60, you sneaky, sneaky people, by producing 496 gallons of the old process and 912 gallons of the new process. Cool. All right, and now what if they wanted to restrict it all the way down to 2144? So this would go down to 2144. And now we would obviously have those two, so it would, let's just get rid of those points. It'd be this point, and it would also be this point. So it would be 0.1072, which is going to give me a profit of 21440. And then I'm also going to check this one, which is going to give me 268, a profit of 18760. So my maximum profit would be $214.40 by producing 0 gallons in the old one and producing 1072 gallons at the new process. Awesome. Wow, that was a long one. That was about an hour, but I think for the most part, I did almost every question. All right. Awesome. Best of luck, guys.